Hello everyone, welcome to my new video. So today we are going to solve another question using topological sort. So the name of the question is minimum height trace. So the question says that you have given a tray which is unidirected graph in which any two vertices are connected by exactly one path. In other words, any connected graph without simple cycle is a tray. Given a tray of n nodes labeled from 0 to n minus 1 and an array of n minus 1 edges where edges I where there is an edge between AI and BI indicates, right? And you can choose any node of the tree as a root. When you select a node X as a root, the result tree has a height h. Among all possible rooted trees, those with minimum height, that is minimum h, are called minimum height tree, MHT. Return the list of the MHT root labels. You can return the answer in any order. So let's say you have given here edges that are connected. So these are A and BI. So it's a unidirected graph. So there is a edge between 1 and 0, 1 and 2, and 1 and 3. So let's see. So there is a edges one, 0, 1 and 2, and 1 and 3. So here let's take 0 as a root. So 0 is root here. Then we can connect 0 with 1, and from 1 we can move to 2 and 3. If we choose 1 as a root, 0, 2 and 3. If we choose 2 as a root, we can move to 1, and from 1 we can move to 0 and 3. If we take 3 as a root, from there we can move to 1, and from 1 we can move to 0 and 2. So here the height is 2. Here the height is 1. Here the height is 2. And here the height is 2. So our answer is this. So at root, if we take 1 as a root, it will give us the minimum height tree. So our answer is 1. So step first, I will create an adjacency list. I will create an adjacency list. Step second, I will create an array where I'll map in degrees. In degrees means how many incoming nodes are there. So if you say in this one, there is only one incoming node. In this one there is only one incoming node. In this one there is only one incoming node, but here in this one there are total 3 incoming nodes, right? So those with the largest incoming nodes is the only way to connect with most of the leaf nodes or most of the nodes. So in case here the incoming nodes is maximum, that is 3. So it means I can make this as a root, so I can connect with more number of nodes. So here you can see I can connect with 3 nodes here, right? So I can take this as a root. So yeah, only we have to follow these 2 steps. And there is one more concept, and that is how many roots we can have. Like how many roots are there in a tree that that are going to give us the same height, putting tree in a horizontal manner. So let's see, 1 2 3 4 and 5. So this is my tree, and if I ask you like which one should I choose as a root so that I can get a minimum height, so I'll take this 3 as a root because this is in the center, and from here I'll get the minimum height. So you can see 2 4 1 and 5, right? And if I make a even number tree, that is 3 4 5 and 6, so either this or this, if we choose any of them as a root, it's going to give us the tree of same height, right? So we have two numbers that we can choose as a root for our tree. So that's what we are going to do. So here the answers are going to be root 1 and root 2, and in this one there is only one answer, that is root. We have given n number of nodes from 0 to n minus 1. So if n is less than or equal to 1, we are going to return. So firstly we'll create a vector with min height, and we'll push this dot push back 0. That's going to our base condition. So we'll return this min height. I need to create an adjacency list, so for that I'll choose an unordered map with int comma int. I named it as graph, and I need to maintain the int degree of every node, how many nodes are incoming in that node. So I'll choose this. I'll map that int degree with that particular node. So let's create an adjacency list for auto I edges. Minimum int degree is going to be 1 because we have a unidirected graph. So what I'll do, I'll create a queue and push all the nodes with int degree 1 inside that queue. Now we know that int total nodes equal to n, and while total nodes is greater than 2, because we know that in the end we can either have 2 nodes, max to max 2 nodes, or 1 node that can give us the same height. So in the end we have to return a list, so it can be either of 2 nodes or a single node. So I'll only run up to 3, and here total nodes and that's all. This will, I think, cover everything, and in the end there are 2 remaining nodes max to max inside our leaf nodes, so we have to push that inside our minimum height array, vector array that we created at very starting, as you can see, and we have to return this minimum height array. So So yeah, accepted. Yeah, thanks for watching the video.